Matter is anything that takes up space and has mass to it. So if it is something that has mass to it and takes up some space, we're going to call that matter. Things like heat and light are not matter. They have no mass and they do not take up space. So it's important that you make that distinction on that being the definition for matter, and that, of course, obviously will be on the test. The building blocks of matter are atoms, and atoms can be put together in many different ways. Unlike the Legos that you can get sometimes and they only fit in certain ways, these can be put together in different ways, and that can help determine what the properties are, and it also gives us a variety of different compounds, etc. So what the types of atoms that are put together will help determine the structure of the matter. So it is determined by the types of atoms that are put together, how they're put together, and how they are arranged. And to understand that, we must know how they make up elements. Elements are made of all the same atoms, where compounds are made of different atoms. It's important that you'll know for the test that elements are made of the same matter, but how those atoms are put together and attached to each other give the matter its properties. So let's look at what an atom is. All right? An atom is made up of three basic parts. It's made up of a proton, a neutron, and electrons. You'll notice that the nucleus, or the center of an atom, is made up of its protons, which have a positive charge, and their neutrons, which have no charge at all. Located in the nucleus, or the center of the atom, you will find your protons and your neutrons. Protons have a atomic mass unit of 1, so it's the weight, the mass of a proton is 1 AMU. Neutrons have no electric charge, but they also have a mass unit of 1 AMU. So that is where the weight or the mass of the atom is. It's in the nucleus, it's in the center. The center is also a positive charge because it has positive protons in it and neutral neutrons in it. So the center, or the nucleus of the atom, has a positive charge to it. So it's important that when you look at a periodic table or you look at atomic particles, that you're able to tell where to find the protons, where to find the neutrons, and where to find the electrons. That will be on the test. The atomic number, which is the top number on the periodic table square, will tell you the number of protons. The bottom number is the atomic mass, or sometimes also known as the mass number, and that is the mass of the atom. The mass of the atom is the weighted average mass of the naturally occurring element and its isotopes. That is what the mass is. That is why we have such an odd number at the bottom. It's not a whole number. So the number of protons in an atom is equal to the atomic number of the element, which you find on the top of the symbol on the periodic table, just like we talked about. Electrons now are negatively charged, and they have very, very little mass. They are located outside the nucleus in a cloud, and it equals the number of protons. So your atomic number equals your number of protons, which also equals your number of electrons. The mass number of an atom is equal to the number of protons plus the number of neutrons. So if I want to find the number of neutrons, I'm going to take the atomic mass, or also known as the mass number, minus the atomic number. So to find my number of neutrons, I take my bottom number minus my top number. That will give me my number of neutrons. We know that we cannot change the number of protons. If I change the number of protons in an atom, it's going to make it a different element, or a different type of atom, so that can't be changed. Sometimes we have elements that have different numbers of neutrons in them, and those are called isotopes. And these exist naturally in nature. And so That's why when we have our atomic mass, it's the weighted average of the naturally occurring elements and its neutrons that occur naturally. There's less of them. Just like in our isotope activity that we did, where you had to calculate the atomic mass and you don't get a whole number because of it. Some examples of isotopes are hydrogen 1, 2, and 3. These are all isotopes. And you can tell they're isotopes by looking at this chart because they have a different number of neutrons than the naturally occurring element. Other examples of isotopes are carbon 12 and carbon 14. It's important that you know and understand what isotopes are. Also, you need to know and be able to recognize what ions are. So if you're given a whole bunch of numbers or information from about different elements, and if they have the same number of protons, thus the same atoms, but they have different number of electrons, then they are ions of each other. And this occurs when elements lose or gain electrons. Gives an element a charge. So if I lose electrons, it gives it a positive charge. And if I gain electrons or get more of them, it gives them a negative charge. This is really important because it gives us ionization. And we all know from learning about electric fields in our last unit that positive and negatives, when they get close enough, are going to be attracted to each other. So it plays a role in the combination of different elements to make compounds. Here's our periodic table. It's important that you know where the atomic number is on the top. So for example, in oxygen here it's 8. That's our number of protons. It's important that you know that our atomic mass, also sometimes known as the mass number, is the bottom number, and for oxygen it's 15.9994. Again, it's not a whole number. We've discussed why that is. We have metals, nonmetals, etc. on our periodic table, and we have our noble gases on the end. There are many models over the years of the atomic structure and how atoms are made, and the current atomic model is that we have our nucleus, like we talked about, with our protons and our neutrons in the center, but our electrons, they fly around the outside. And so they don't fly around in a single orbit. They fly around in these clouds where they'll bounce around and they'll come up and down and that type of thing. So it's much more of a cloud around the nucleus that these electrons will stay in those certain areas. We have about 90 naturally occurring elements on Earth, and these can combine in many, many different ways and combine to form many, many different compounds. We know that there are more than 90 elements on the periodic table, but some of them are synthetic or man-made. These can combine, atoms can combine to give very unique combinations. The properties that you observe when a substance changes to a new substance is called a physical property, and this does not require a physical change. Density is an example of a physical property. You need to know density. You need to know the formula is mass divided by volume. Density is measured by the mass of an object, and you divide it by its volume. It is a physical property of an atom. Physical chemical properties of matter don't change when the matter changes state. So some of its physical properties change. So as it goes from a solid liquid to a gas, its chemical properties aren't changing. It's still going to be whatever that element is. So water, when it goes from solid liquid to gas, it's still water. It's still H2O. It only changes its physical properties. And the density of water changes as water changes its state. Ice floats in liquid because it's less dense than liquid water. Density of an object that's more dense than water will sink in water, and that's important for you to know, and that's something you'll probably get tested on throughout your lifetime. On the other hand, if the object has less dense than water, it will float. We know that the density of water is about 1. Chemical properties. When one substance reacts with another, it's called a chemical property. It depends on atoms and how they are put together. So the chemical properties of an compound is based on how the atoms are put together, or even of the element. The forces that, and also the forces or the bonds that hold them together, that will all help to determine what those chemical properties are. Different types of bonds. First, we have covalent bonds. And what I want you to know about those is that they are sharing electrons. That this is what is a weaker bond. It's between two nonmetals, and it's what makes up molecules. The next type of bond is ionic bonds. And when they become positively or negatively charged, when they form ions, they can come together and form an ionic bond. And these are usually between metals and nonmetals. They're electrically charged atoms, and they're called ions that come together, and opposite charges attract. The last type of bond is hydrogen bonds, and this is easily broken. It's the weakest of the three bonds, and it's indicating that the charges are weak, and so that will help to determine some of the chemical properties. It is also what gives water its unique properties, something that you'll learn more and more about as you go through your sciences. So, we have what we call mixtures. And mixtures is a type of matter. So matter is our big umbrella, and under it is mixtures. And it can be when you have two or more substances that are not chemically combined, but they come together. So things that we put together, we don't chemically combine them. Dissolving water or sugar or salt, in water is an example of a mixture. A lot of our foods are mixtures: fruit salads, pizzas, those type of things. A heterogeneous mixture is mixtures that are not mixed completely. They don't look as one. So salad, pizza, those type of things. Homogeneous mixtures are mixed completely, like the salt water or the sugar water that we talked about. The other type of thing that we have besides mixtures is pure substances. And there are two types of pure substances. Number one, there are elements, which are made up of all the same atoms. And number two, compounds that contain different types of atoms that come together and chemically bond together. Anytime I can write a chemical formula or I can find it on the periodic table, it is a pure substance. So I have matter. It's broken down into mixtures and pure substances. Mixtures are broken down into heterogeneous and homogeneous and mixtures. And pure substances are broken down into elements and compounds. So, separating mixtures and compounds. The components of a mixture can be separated just by physical means, by picking them out, separate them. The substances in a compound must be separated by chemical means because they are combined chemically. So, states of matter. On Earth, there are 4 physical states of matter: solids, liquids, gases, and plasmas. Solids are in fixed positions, and they're very close together, and they do move, but they vibrate back and forth. They have a definite shape and volume. Liquids, because I add more energy through heat, they begin to be more active. They have more kinetic energy. They have no definite shape because of that, because they will take the shape of whatever you put them in, because the molecules are farther apart and they move around. Gases have even more energy, so much so that they no longer are attracted to each other. They will fill the canister and they'll bounce all over the place. And as these atoms bounce off of each other, they transfer the energy from one atom to another. Plasma is the most common state of matter in the whole universe, not just on Earth, but in the whole universe. It's associated with very, very high temperatures. So things like stars and stars like the sun are composed primarily of plasma. It's important that you know all these states of matter, and that you know the difference between solids, liquids, gases, and plasmas. Also, on Earth, the plasma is found in lightning bolts. So these are all the things that you need to know for your tests, along with that as things change in the states of matter, these give us our properties of our matter. So our freezing point is when we go from a liquid to a solid. Boiling point is a liquid to a gas. The changes in state also occur because we increase or decrease pressure. So the two things that can change our states of matter is temperature change and increase or decrease in pressure. Also, you need to know this for your test. Water is the only substance that occurs naturally on Earth as a solid, liquid, and a gas. Keep studying, and good luck.